8.2 Notes, Graphs of the Other Trigonometric Functions, page 3. We are going to start by graphing the tangent with no phase shift and no vertical shift. We want to just take a look at some of the properties of tangent, figure out how we're going to graph these before we start moving it around. Okay. So the general form of the tangent without a phase shift is right here. Y equals a tangent of bx. And so we want to graph one period of y equals 3 tangent pi over 6x. Okay. Try to color code here. A is our 3, so our stretch factor is 3. The period is pi over b, so we've got pi over 6. Just a reminder that that's pi divided by pi over 6, which we can rewrite as a multiplication, which gives us a period of 6. And so we go back and forth sometimes between having functions that have periods in terms of pi and periods in terms of whole numbers or rational numbers. It doesn't matter a whole lot. They're all still numbers. Okay. So we have got vertical asymptotes at negative p over 2 and p over 2, where p is the period. So we're at negative 6 over 2. So x equals negative 3 and 6 over 2. So x equals 3. And so let's think for a minute about why this is. If we have not shifted this function at all, it's centered at 0. And so if there's a period of 6, half of that period has to go to the left, half has to go to the right. So I'm going to go ahead, 1, 2, negative 3, and stick these asymptotes in. 1, 2, positive 3. Okay. Might as well get the y-axis here. I'm just gonna 2, 4, and that should work for what we've got going on here. Okay. Our vertical asymptotes are at x equals negative 3. It's a little repetitive. X equals 3. And just so we're clear, we've got these two vertical asymptotes. And just a reminder that our graph is not going to cross those asymptotes at all. Okay. So the other thing that we looked at when we started looking at the graphs of tangent is where the 1s were. So if our period was 1 pi and we split it at the origin, and so pi over 2 to the left, pi over 2 to the right, and then we split those in half, that would be our pi over 4. That's where our tangent's going to be 1 or negative 1. Okay, so we're going to use that reference point, the p over 4. That is not approximating our pi over 4. That's modeling our pi over 4, depending on what our period is. So we've got 6 over 4. A is that multiplier out front. Keep in mind, I meant to make that 3 over 2. That where the tangent is 1, it's being multiplied by the 3. That's why that y value here is 3. I got negative 6 over 4, negative 3. So negative 3 halves, negative 3. And then we've also got that center of the period, the 0. So we're going to start with 0, 0. I've got 3 halves. So right here, up to 3, negative 3 halves, negative 3, and that really is all I need to graph my tangent. If I wanted to, I could extend this out here. Okay, but what we're primarily concerned about is that single period that is bounded by -3 and 3.